Okay, good morning students. In this session I will discuss about the some of the problems for inverse Z transform. So, inverse Z transform. So, what is the need of inverse Z transform? To get backward signal in time domain. What is the x of Z transform is given for the first problem 3z squared plus 2z plus 1 divided by z squared plus 4z plus 3. This you can write, you can divide this 3z squared plus 2z plus 1, z squared plus 4z plus 3. So, 3 z squared 3 12z okay, plus 9 8 minus 10z minus 8, you can write 3 plus minus 10z minus 8 divided by, so z squared plus 4z plus 3. So, by partial fraction method, so x of z you can write 3 by 3 plus a1 by z plus 1 plus a2 by z plus 3, because the factors are 4 and 3. So, 3 1 and 3. So, z plus 1 and z plus 4. So, now determine the value of a1. How to determine the value of a1? A1 you determine, so which is equal to z plus 1 into, that is minus 10z minus 8 by z plus 1 into z plus 3, where z equal to minus 1. So, this will be cancelled. So, you substitute the value of z is equal to minus 1. So, a1 will become minus 10 into minus 1 minus 8 minus 1 plus 3. So, 10 in 10 minus 8 by 2, 2 by 2, which is equal to 1. So, a1 is equal to 1. Similarly, you find a2, which is equal to z equal to minus 3. So, you will get a2 value. So, z plus 3 into minus 10z minus 8 divided by z plus 1 into z plus 3, where z equal to minus 3. So, this will be cancelled. So, we will get substitute this minus 3 value, minus 10 into minus 3 minus 8 divided by minus 3 plus 1. So, that is 30. Okay, 30 minus 8. So, this is 30 minus 8 by minus 2. So, 22 by minus 2 you will get 11. So, a2 is equal to minus 11. So, now x of z can be written as 3 plus 1 by z plus 1 and minus 11 by z plus 3. Okay, so multiply and divide by, you can multiply and divide by z. So you will get 3 plus this is x of z. So multiply and divide by z, you will get 3 plus yz. Okay, so this become, you can write, so 1 by z into, you get z by z of minus 1 minus 11 1 by z, z divided by z of minus 3. So you can write 3 plus z inverse, okay, z by z minus of minus 1 minus 11 z inverse z by z minus of minus 3. So you can, why I am writing this one, you can apply directly the property and you can take inverse Z transform. Take inverse Z transform. So there is a x of n will be, okay, there is del n will be 1. So 3 into del of n plus here this shifting property. So this is a shifting property z per minus n. This is a shifting property, and right, this minus 1 per n into u of n minus 1 minus 11 minus 3, this minus 3 per n 3 power 3 power n minus 1. So minus 1 is minus 4 n minus 1 to u of n minus 1 minus 3 n minus 1 into u of n minus 1. Okay, so this is a common term you can take. So this is the inverse Z transform. So 3 into del of n, and it's also, let's wait. Into del of n plus, okay. So one more problem, second problem what we have discussed, x of z is equal to 1 divided by 1 minus 1 point z inverse plus 0.8 z minus 2. So what are the conditions are given? First condition, for the following ROC conditions are given. If z is greater than 1, if z is less than 0.8, the third case z is greater than 0.8 and less than 1. So the numerator polynomial n of z equal to 1. Okay, so that is the m equal to 0. So m, this is actually m equal to 0, and this is m value, m equal to 0. This is n value is equal to 2, n is equal to 2. So now you can take, so this x of z you put in a proper form, because the denominator term is 1 minus 1 point, so b naught is equal to 1. This is b naught value. If b naught is equal to 1, this is bn value. This is bn value. b naught is equal to 1 and bn is equal to 0.8, and this m is less than n. So these are the conditions, because a naught plus what is the, how you can write x of z is equal to a naught plus a1 z minus k. So we hope that you remember that equation x of z is equal to, so the system function k equal to 0 to m and a k z minus k divided by the summation of k equal to 0 to n b k into z minus k, and this can be expanded, and finally you can write z minus z1 into z minus z2 z minus zm divided by the poles z minus p1 and z minus p2 z minus pn. So a naught, so actually this will be a naught by b naught into z power n minus m. So this derivation we already discussed is a gain, called gain. G is called, this is x of z. So G is called the gain of x of z, and it does not affect the poles and zeros. Okay, z power n minus m. So this n minus m, so it's a gain. So the gain of x of z, it does not affect the poles and zeros. So how the poles are located? Okay, so depending the z power n minus m, if conditions are, if n is greater than m, if n is here, what is the value? M is should be less than n. Okay, if m is less than n, then the x of z has n minus m zeros at the origin. Conditions are there. If n is less than m, then the x of z has m minus n poles at the origin. So as z tends to infinity, x of z will be infinity. There is a pole at z equal to infinity. If x of z equals 0, as z equal to infinity, there is a 0 at z equal to infinity. Okay. So we will take the problem. So these are some of the concepts to determine the stability of the system. So you can write x of z is equal to 1 by 1 minus 1.8 z inverse plus 0.8 z minus 2 multiplied by z squared by z squared. So if you multiply this one, then z squared by z squared minus 1.8 z inverse plus 0.8 1 minus multiply and divide by z squared. So z squared minus 1.8 multiply z squared minus 1.8 z plus 0.8. Okay, now you can write x of z by z is equal to z by z squared minus 1.8 z plus 0.8. This now you can write z by z minus 1 into z minus 0.8. So 0.8 to minus 1.8 is the residues. Now you can write by using partial fraction method a by z minus 1 plus b by z minus 0.8. So to determine the value of a is equal to z minus 1 into x of z by z, where z equal to minus 1. So z minus 1 into, what is the x of z? X of z is z by z minus 1 into z minus 0.8. So it will be cancelled, where z equal to minus 1. So now minus 1, that is equal to 1 plus 1. So 1 by 1 minus 0.8, 1 divided by 0.2, 10 divided by 2, which is equal to 5. So a is equal to 5. Similarly you can find out the b value. So that is z minus 0.8 into x of z by z, where z is equal to 0.8. Now similar way you determine the b value, z minus 0.8 into z by z minus 1 into z minus 0.8, where z equal to 0.8. So this will be cancelled. So substitute the value. So we get 0.8 by minus 0.2, will get minus 4. So now substitute the value of x of z by z equal to a by a value is 5 by z minus 1 plus b value is minus 4 by z minus 0.8. So now you can write x of z is equal to 5 into z by z minus 1 plus minus 4 into z by z minus 0.8. Okay. Now what are the different conditions they given? The first condition, ROC and the monoid is greater than 1. So the time domain sequence will be this will be causal. Okay. Then take x of n. So take inverse z transform x of, take inverse z transform. Is it? Take inverse z transform to get x of n. Okay. So x of n is equal to, x of n is equal to 5 into, take this z transform of inverse z transform, this one will be 1 divided by 1 minus z inverse minus 4 into 1 divided by 1 minus 0.8 z inverse, right. So which will be equal to 5 into, this is 1 power n into u of n minus 4 into 0.8 power n into u of n. Okay. Next to the condition, this is for ROC modulus of z is greater than 1, will be causal. So this is will be the time will be causal. Second one, second ROC, the modulus is less than 0.8. less than 0.8. Condition is given less than 0.8. That means what is the result? Less than 1, which means 0.8 means less than 1. Therefore, the signal is anticausal. Signal is anticausal, less than 0.8. So, in that anticausal, you have to take the x of n is equal to the inverse z transform of x of z. So, in that case, you take 5 into the inverse z transform of 1 by 1 minus z inverse minus 4 into the inverse z transform of 1 by 1 minus 0.8 z inverse. Since it is anticausal, you can write 5 minus 1 power n into u of minus n minus 1 and minus 4 minus 0.8 power n into u of minus n minus 1. So, this is required for the anticausal. The third condition is the last condition, ROC if it is greater than 0.8 and less than 1. So, third condition will be, you can write x of n is equal to minus 5 1 power n into u of minus n minus 1 and minus 4 into 0.8 power n into u of n. This is less than 0.8 for anticausal and less than 1, 0.8 per n into u of n. The last problem, what is the one more problem I given, 7 minus 6. Last one will complete. The problem is h of z is equal to 7 minus 7.6 z inverse divided by 1 minus 2.4 z inverse plus 0.8 z minus 2. So, you have to find the ROC, specify the ROC and find the unit, specify the ROC and find the impulse response of the system, that is the h of n. So, h of z, then you take inverse z transform. Then what are the conditions they given for stable system, causal system, anticausal system. So, you can write h of z is equal to 7 minus z inverse you take outside. So, 7 is z minus 7.6 divided by z minus 2, take it common. So, z squared. So, this is z square 1, then minus 2.4 z. So, z minus 1 and plus 0.8. Then h of z by z will get z into 7z minus 7.6 divided by z squared is 2. So this z squared minus 2.4z plus 0.8. So it will be cancelled. Okay. So z plus 2 should be cancelled. So z should divided by z. It will be correct only. So that set will be cancelled. This z will be cancelled. The numerator term will be 7z minus 7.6 divided by the denominator term becomes z minus 0.4 into z minus 0.2. So 0.8, 0.4 into 0.2. 2. This is not 2. 2 into 0.4, 0.8. Okay. This is z minus, sorry. Z minus 2. So now apply partial fraction. Okay. A by z minus 2 plus b by z minus 0.4, which is equal to, now find a value, z minus 2 into h of z by z, where z equal to 2. So this is h of z by z. So z minus 2 into 7z minus 7.6 divided by z minus 0.4 and z minus 2, where z equal to 2. These two are cancelled. So substitute these values. 7 2s are 14 minus 7.6 divided by 2 minus 0.4 will be 1.6. We will get 6.4 by 1.6, which is equal to 4. So a is equal to 4. Okay. Similarly, you find b value. So b is equal to z minus 0.4. Simply I am not doing, I am step by step deriving. Similarly, you have to derive. So of z by z, where z equal to 0.4. So now z minus 0.4 into h of z by z will be 7z minus 7.6 divided by z minus 0.4 into z minus 2, where z equal to 0.4. Z equal to 0.4. So we will get b is equal to 7 into 0.4 minus 7.6 divided by 0.4 minus 2. So we will get 48 by 16, 3. So how h of z you can write, h of z is equal to, h of z by z equal to a by z minus 2. Okay. Sorry, what is the a value? Substitute 4. and plus b by z minus 0.4. So h of z is equal to 4 into z by z minus 2 plus 3 into z by z minus 0.4. Take inverse, so you can write 4 into 1 by minus 2 z inverse plus 3 1 by 1 minus 0.4 z inverse. Take z transform, take inverse z transform, the unit sample response is given by unit sample response h of n is equal to 4 into 2 power n into u of n plus 3 into 0.4 power n into u of n. The two poles are at z equal to 2 and z equal to 0.4. Okay. So what is the ROC now? So ROC, if you find ROC, so this is the largest pole. So how do you draw? Okay, so 0.4 also. So the inner circle radius, and is a one pole at so that equal to modulus of z equal to 0.4. The other one 0.4. So next one is unit circle. The unit circle is a unit circle z equal to so unit circle 1. Okay, so this is the modulus of z is equal to 1. The other largest pole is, I will take green color. Okay, 1 2. This is 1 now, so 2. Okay, so what about this radius? This is equal to 2. Now the ROC, you define the ROC. Okay. So in this so this area is ROC totally for this system function. This is ROC. This is because the largest pole is 2. Outside the largest pole ROC, so this is only causal system. ROC, this is causal. So for a causal system, the ROC will not contain any poles. So the ROC for the system to be causal, it will be modulus of Z is greater than equal to 2. So the causal system, it should not contain any poles. Anti-causal system, the ROC will be the interior to the circle. Here modulus of Z less than 0.5, 0.4. Therefore the ROC of interior to the circle. So that the ROC of the 0.4, so the ROC of Z equal to less than 1. This ROC, this is less than 1, anti-causal, so less than 1. So the impulse response you can write, in that case the impulse response will be anti-causal minus 4 2 power n minus 4 2 power n u of minus n minus 1 minus 3.4 power n u of minus n minus 1. Okay, u of minus n minus 1. Since ROC there is a modulus of less than 0.4, it does not contain. So this one it does not contain this ROC less than 0.4. It does not contain unit circle. It does not contain unit circle at a modulus of Z equal to 1. It does not contain the unit circle. So ROC does not contain the unit circle. So conclusion, ROC does not contain the unit circle. ROC does not contain the unit circle. So therefore the system is unstable system. Okay. So hope that you understood the complete Z transformation and inverse Z transformation. So many problems we have solved, and apart from that you can take exercise problems from the prescribed textbook. John Prokis or opening, by practicing it will be easy to understand the concept of how to determine the stability of the system. So some of the examples I can give. See, X of is the determination, representation of pole and zeros in z plane. So x of z is equal to 0.5 minus 0.4 z inverse plus 0.06 z inverse divided by 2 plus 1.6 z inverse plus 0.64 z minus 2 z minus 2. You simplify this equation. So take this problem and represent, so simplify, and whatever the zeros of the numerator polynomial. So if you can find the two poles 0.6 and zeros 0.2 poles, these are the zeros. Check the answers. Poles are the denominator term z squared plus 0.8 z plus 0.32 poles denominator term, which is also equal to 0. So in that case z equal to minus 0.8 plus or minus root of b squared minus 4ac by 2a b squared minus 4ac by 2a. So you will get minus point plus or minus j 0.8 by 2, this is equal to 0.4 plus or minus j 0.4. So you can write the equations: z plus 0.4 minus j 0.4, and other roots are poles are z plus 0.4 plus j 0.4. So how do the poles are P1 and P2? So P1 is equal to 0.4 plus 0.4 j. So 0.4, P1 will be minus 0.4 minus 0.4, 0.8 minus 0.8 minus 0.8 minus 4 plus or minus 4 plus j 0.4. Similarly for P2, minus 0.4 minus j 0.4. So how do you plot the poles and zeros? So already the zeros determined. The poles are the two complex zeros are z equal to 0.6 and z2 equals to 0.2. So how do you plot the poles and zeros? Okay, take green color. So the minus 0.4 and plus j 0.4. So scale 0.2, 0.4, 0.6, 0.8. So here 0.2, 0.4, 0.6, 0.8. Minus 0.4, how do you represent the term? 0.2, 0.4, 0.6. Point 6, 8, 0.8. Similarly here 0.2, 0.2, 0.4, 0.6, 0.8. So to the poles pi minus 0.4 and plus j 0.4 is plus j. This is minus j. Sigma plus j. Okay. So poles are minus 0.4 plus j 0.4 poles the other one is minus 0.4 minus j 0.4. These are the poles. And this will be okay. The zeros are 0.2 and 0.6. Zeros are 0.2. Zeros are indicated by 0.2 and 0.6. This 0.6. Z1 and Z2. This is P1 and this is P2. So this is a pole 0 representation. Okay. So for the given transfer function, so we have determined the pole 0 concept, pole zeros, and plotted in the Z plane. Okay. I think you understood the Z transform and the properties of Z transform and the importance of poles, determination of poles, and how the poles plays a vital role, whether the given system is stable or unstable. Okay, thank you.